Okay, this is a solution to one of the problems from section 3.3. In this problem, we're using the regression line that's given, so we don't have to find that out. But we do have to pay attention to the units because this is a problem in the context in a context of what the variables stand for. So it tells us that the response variable is the selling price in thousands of dollars. So that's important. So if we get a Y value of 100, that means that the sale price is $100,000. So whatever number we get, we put $1,000 at the end of it. Similarly, it says the explanatory variable X is the size of the house in thousands of square feet. So if we want to say we have a 2,000 square foot house, then that means our X should be 2, because the number 2 followed by thousands of square feet would then describe the house. So we have to be ready for things like that, where we have to pay attention to the units to make sure that we're reading the question correctly. So the first question asks us just to make a prediction based on our linear regression model for two different house sizes. So just write A over here. So the first one asks us what we think the price should be if the house is 2,000 square feet. So that means X should be 2. So in the model, 9.5 plus 77.3 times 2. If we do that, we get 164.1. And so again, we have to interpret that as thousands of dollars. So $164.1 thousand. So that's a little bit weird to look at. So in the answer, they want us to put it in actual dollars, not in thousands of dollars. And so we have to move the decimal place so that it says $164,000. So basically, we're moving the decimal place 3 places to indicate that it's thousands of dollars. So that's where they get the answer for 1. The second value to plug in is 3,000. So if you got that one right, then I'm sure you got this one right, because we're doing the same thing. We get 3, and so when you plug that in, you get $241.4 thousand. And so if we write that in just plain dollars, it would look like $241,400. So that's where they're getting the answers that go here. Now, the interpretation of slope, remember, is the slope is, of course, here. So it's this number that's in front of the x. And so the general interpretation is, is for every increase of x by 1, the y, this is a positive number, 77.3, so the y increases by 77.3. So that's the interpretation of slope, is for every 1 unit you increase the x, the y should change by whatever the number for slope is. So we do want to make sure we remember what everything is measuring. The x's, remember, are measuring the size of the house, and the x is in thousands of square feet. And so this statement, for every increase of x by 1, should be for every increase of 1,000 square feet in the house. So we're looking at either B or D are the only ones that talk about for every increase of 1,000 square feet in the house size. The y increases by 77.3, but remember the y is measured in thousands of dollars. So we should be seeing that the house price should be increasing by $77.3 thousand, or $77,300. And so that is this guy. Increasing the x leads to an increase in the y by the slope. They're not included on this particular page, but we also have a C and a D part. So let me just answer those. The correlation coefficient is not given here, but we know it's going to be positive simply because the slope is positive. So the correlation is positive if the slope is positive. So it's not a coincidence that when you have an R value, a correlation coefficient that's positive, it always goes with a slope that's positive. And when your correlation coefficient is negative, that the slope is always negative. The correlation coefficient is not the slope, but the correlation coefficient being positive or negative is always the same as the slope being positive or negative. The question D builds off of the one that we just answered. It says the home that's 3,000 square feet, that's the one that we got this prediction for here. So this is our predicted value, remember. They're saying, well, what if we actually knew that that house sold for 3,000? So we still know what our prediction was, but they're saying in part D, suppose you know that the real Y, the true Y, is 300,000. And it's asking then what's the residual for that? Well, the residual, that's in dollars, the residual is just the difference. So you're going to subtract, if you use our residual formula, you're going to subtract the true Y minus the predicted Y, and that's your residual. So in this case, it's just 300,000 minus 241,400. So that's an easy calculation because you're using the same value that we already got our prediction for.